Hey, chemistry, biology, and middle school science. This is Doc again. Good to see you. Today, I want to review what we talked about in Tuesday's video about the valence electrons and how we determine what molecule has how many valence electrons, and also then try to help understand how the atoms that are part of the elements combine with each other to form molecules. Now, a couple of videos ago, I used candy to make some molecules, and I did them in a certain way, and we talked about the bonds and all that. Today, I want to explain how we know those bonds are accurate. All right. So the first thing that we want to do is go back and do a little review. And if you remember, we can get all the information we need about the valence electrons from the periodic table. So remember, I was hoping you guys were able to find one of these or print one of these off. But it starts from all the way over at hydrogen to helium. Okay, and we count 1, 2, we skip this row, 3, 4, 5, 6, 7, and 8. And that is the most important thing, is that by counting from 1 to 8, those numbers, we saw a pattern develop that every column, all the elements in every column have the same number of valence electrons. That's why they put them in those columns that way. Okay, so I'm going to show you one more time with a blank, and we go for hydrogen. There's a 1. Then there's a 2 for this column. We skip these guys. Then we go to 3, 4, 5, 6, 7, 8. And once you put the elements in here, if you guys did the assignment where you were taking a blank sheet of the periodic table and filling in the elements, then you'll see where oxygen goes, where carbon goes, where nitrogen goes, where fluorine goes, where hydrogen goes, where helium goes. And what you'll see is a pattern that everything under hydrogen, for example, like the lithium and sodium, they too just have 1 electron, and they're in row 1. They just have 1 electron in their valence, in the outer shell. Okay, so what does that tell us? Well, let's review. When we know the number of electrons that are in the outer shell, it can help us draw the Lewis dot formation. So here is carbon, right here, and it is in row 4 when we count across 1, 2, 3, 4. And lo and behold, how many electrons does it have in its outermost shell? 1, 2, 3, 4. Okay, so now we know we have to have 4 dots that we need to put around carbon. And we do it like so, all the way around. And what you can do is, you can imagine that there is a square around each element, just like in the periodic table, and put your dots on the square. And that way, when you put 8 dots, you'll have 2 dots on top, 2 dots on side, 2 dots on the middle, and 2 dots on the bottom. Okay, so if I take this carbon right here, and let's change it to an oxygen. Change it to the letter O. Like so. Now again, the dots aren't right now because that's C. Carbon is in the 4th row. Then you have nitrogen, and then in the 5th row, and then in the 6th row you have oxygen. So oxygen is supposed to have 6 electrons in its valence. So we only have 4 here, so I have to add 2 more. And we do that kind of in a clockwise motion. But I notice that I am putting them on the square. So there's oxygen, okay? Notice it has 2, 2, 1, and 1, okay? And that's how you do the Lewis dot formation for oxygen. Now, let's say we wanted to combine oxygen with hydrogen. Well, when we take a look at hydrogen and how many dots it does have, it's in row 1. So it only has 1 dot, right? Because it's in row 1, just like lithium and sodium, okay? So how am I going to combine hydrogen? What is it going to want to do to combine with oxygen? Well, when we put the two side by side next to each other, we can kind of figure out maybe what we'll be able to do to connect them, because that's what bonding is just connecting the elements or the molecules. Okay, to make a molecule, you're just combining the elements. And if I draw it like something like this, there's my oxygen with my 6 valence electrons, and there's my hydrogen with my 1. It kind of looks like hydrogen might be able to take its electron and kind of share it over here and fill this blank, because ultimately the elements would like to be full on the outside and have 8 if they can, or 2 in the case of helium and hydrogen. They only have 2, one shell with 2 when it's full, right? But the other ones have 8 till you get to the bigger numbers, okay? So how are we going to make it so that there's 8 electrons for oxygen and 2 electrons for hydrogen? Okay, well, what we're going to do is, I'm going to simplify it, but I'm going to draw another H and put a dot over it and draw it kind of next to it down here, and this one over there. And maybe you guess what I'm going to do. I'm going to take this electron and we're going to plug it in there. We're going to share it. I'm going to take this electron and I'm going to plug it in over here and share it, okay? So I'm going to, in red, I'm going to do that in red just to kind of diagram what happens. If that makes sense now. See how I have the electrons going to be shared? They're going to go in there and that's going to fill up. Oxygen will be happy because it'll have 8 in its outer shell, because everybody wants to have as many as possible in the outer shell to be happy, okay? Hydrogen will be happy because it'll have 2 in its outer shell, which it's trying to do, okay? So I'm going to draw them together now. Same picture, but I'm going to draw them all together with sharing their electrons, okay? So, and I'll put the shared electron in red. How about that? So I'm going to go H. I'm going to draw them in a straight line just to make it look easier. So now, when I take this picture from this picture right here and zoom it in, and we go to this picture right here, where you can see that the hydrogen has its one original atom and it's sharing another one, okay? And just now, oxygen, if you count around the oxygen, how many electrons are around the oxygen? 1, 2, 3, 4, 5, 6, 7, 8. How many are hooked to hydrogen? 1, 2. So everybody's happy this way, okay? There's another way we draw bonds when we have electron pairs like this that are sharing. Sometimes we just draw a straight line, okay? And I'll do that right below it so that you can, actually I'll do that on another piece of paper so that you can see it easier. we still keep the dots for the oxygen. So it would look like that now. So it'll go from having the shared electrons with all dots to having a line like that. Okay? And that is H2O, and that's a water molecule. And that's how we know that it can only have two H's. There's no more room for, let's say, H3O or H4O, right? Or, you know, that's it. That's the full shell, okay? So hopefully that's clarified a little bit about the Lewis dot formation of the dots. Remember, you look in the column of the periodic table. And if I take the periodic table again, and I go from this side where H is 1, 2, skip these, then I go 3, 4, 5, 6. There's oxygen. 6, 7, 8. All those in each column will have that many valence electrons around it, and that'll be the simplest way for you to be able to tell how many outside electrons are in the shell of the element. Okay, hopefully that clarifies things. We'll be getting into this a little more. I'll do maybe 1 or 2 more dot electron type of configurations, and then start doing molecules like salt, and then we'll go into covalent bonds with triple bonds and double bonds, and a little bit more complicated. But for right now, I just want you to understand what we just went over. Okay, so take care, and this is Doc out.